Okay, Ben, thanks for joining me today. We're going to chat about acoustic design considerations at the building envelope level of a project. And I feel like this is a timely topic, Ben, because given the myriad trends we're seeing in the marketplace, it really does hit home for teams and, of course, acoustical design consultants like yourself. So what are we talking about? Trends. I'm talking about activation of rooftop spaces for entertainment and leisure. New approaches to building facade design. For instance, we're seeing jumbo glass become a thing. And how does that impact the acoustic design of that building envelope? More urbanization and frankly, more density in building projects, just more building space and more people in a smaller area. And how does that affect and the noises around that building, and how does that affect the acoustic performance of the building? And then adoption of rating programs that now seem to place more emphasis on acoustic design as it relates to occupant health, wellness, and performance. So Ben, all that being said, I just wanted to set it up, but as an expert in the field, are there sort of 3 or 4 top acoustic design concerns or considerations in the industry right now as it's related to the envelope of the building?
Thanks, David. I agree with you. It is timely. What you mentioned about density is something that we see play out in a number of different ways that absolutely impact the acoustic environment around a building. So one great example of that is transit-oriented development. You've got a bus station or a train station that is by design conveniently located right at the condo tower or whatever that development might be, office building. And when you have transportation sources, those are sources of noise that potentially can keep people up at night. And so that's a challenge, with the bus stop right there outside your window. Not hard to imagine how that potentially could be a noise conflict. Another similar one, also related to density, is the increase in multi-use development. So a phrase that I think developers are fond of using is live, work, play,
Mhm.
right? So we have one project that is multifaceted. It includes residential space, that's the live part. It includes commercial office space where people work, and it includes places for people to play, which may be shopping, it may be retail, it may be entertainment venues. I've worked on projects that have, full blown rock and roll venues in the same building complex as residences and offices and hotels. And that's exciting. It's dynamic. It's part of what makes cities fun to be in. And it does relate to this trend toward urbanization and density. But there's, of course, a built-in potential for noise to impact some of those more acoustically sensitive spaces in close proximity to one another.
This episode of Horizon TV is sponsored by the Bilco Company, the industry leader in the design and manufacture of specialty access products. Unequaled in quality, design, and operation, Bilco's automatic smoke vents protect property and aid firefighters in bringing a fire under control by removing smoke, heat, and gases from a burning building. Bilco's acoustical automatic smoke vents are designed to provide fire and smoke protection for applications where exterior noise intrusion is unwanted. And the vents feature OITC 46 and STC 50 sound ratings, which are the highest on the market. Bilco's acoustical smoke vents are engineered with powerful gas spring operators to open covers in snow and wind conditions, and the product's Thermolatch 2 positive hold release mechanism ensures reliable vent operation when a fire occurs. The vents are constructed with corrosion-resistant materials to provide many years of trouble-free, dependable service, and are available in a number of standard UL-listed sizes. For more information on Bilco's complete line of products, please visit www.bilco.com. BIM models, CAD details, and 3-part specifications can be found on our website to help with your next design project. Our highly trained local sales representatives are always available as well to provide technical support.
A third one is something that you also mentioned in your queue up here, which is the activation of rooftops.
Mhm.
So, for a long time, we've been concerned about rooftop mechanical equipment. And that's not particularly new. Rooftops have been populated with cooling towers and air handlers and so forth for a long time. And that's a perennial topic of consideration for acoustics professionals. What is, I think, more commonplace now is to have a bar, a swimming pool, a bar and a swimming pool, and a music studio, and whatever, top floor amenity spaces and rooftop amenity spaces that um, are activated, that are fun, but let's face it, they are right over top of potentially the most expensive unit in the building, or the office space that has the highest rent, or the CEO suite up there, or whatever the case is. So whether it's multifamily building or commercial building, you've got potentially the very most sensitive acoustic use immediately below what could be a quite active and engaged exterior condition. And that's an important consideration and somewhat new. There are other trends, and I think as we go back and forth, we might talk a little bit more about evolutions in facade design and the relationship in that to sustainability. Some of the stories here are good. There are some synergies here that I think are beneficial to this conversation. It's not all bad news.
Well, and I would imagine, yeah, your firm as a leading firm in this field, you're keeping busy because you think of TOD, multi-unit or mixed-use projects, and then of course those activation of the rooftop spaces. It's hard, you'll be hard pressed to find a project that isn't sort of tied into one of those in the urban area. So I'm sure the AEC teams and building owners are leaning on your firm and yourself to help solve some of these challenges. And that's my next question is like, what are the solutions here when you talk about density, urbanization, rooftop activation, where there's activity above you and to the side? Are there clear and cut sort of measures or solutions that teams could consider?
Yeah, I absolutely. You're right. We're busy. Wouldn't want it any other way. The right answer here isn't to abandon everything that we know that's positive about urbanization and density and walkability and the enormous climate related and sustainability and wellness related benefits to having transit oriented development, to having people be able to live in close proximity to where they work or where they go for entertainment. So these are positive developments for our culture, and we just need, as design teams, to be accounting for these challenges when we're designing buildings. So yeah, what do we do? So a number of things. Part of the conversation has to do with the makeup of the envelope itself, right? So what is the design of the glazing? How is the glazing engaged as part of an overall facade design? With respect to the roof, we can kind of come back to that, but what is the exterior aspect of that, the structural aspect of that, and the interior finishes, the interior ceiling aspect of that. So that roof one is sort of a three-parter.
Mhm.
On the facade, traditionally, the place to focus is in the fenestration. It's in the glazing, right? So are we using insulated glass? What else are we doing? Are there moves that we can make toward laminated glass or thicker glass or capturing deeper air gaps, identifying areas of the building that might warrant secondary glazing, like an interior glazing system that's inboard of the thermal glazing for particularly sensitive adjacencies or particularly loud exterior sources? And thankfully, there's a lot of solutions on the market right now. Not only are there a lot of solutions on the market, but also there is a corresponding energy consumption, energy performance of the building benefit, right? So
Mhm.
as you improve the thermal performance of your facade, most of those moves improve the acoustical performance of the facade as well, and vice versa. So, it's not exactly a one-to-one correspondence, but there's definitely a correlation there. If you're making your facade tighter, and improving its thermal performance, we're going to enjoy all of the energy related benefits of that, and we're going to enjoy some acoustical benefits of that as well. So that's a really nice synergy that way.
We touched on the rooftop situation. You mentioned structural considerations. What else kind of goes into? So you have a top floor penthouse, and then there's a swimming pool or entertainment deck above. And this, buyer just paid $3 million for his penthouse. They're not going to want to hear footsteps and noises. So how can you mitigate acoustical issues there?
That's right. And, we could spend a whole hour just on this because there's a lot that goes into it. But step one is thinking about what the sources are. So, okay, we're going to have a party up there. There's going to be people walking around. So you've got an AV system. You got people walking. So you've got impact, footsteps, as you mentioned. You've got the voices of people. Maybe there's a swimming pool and people are splashing and all of that. There's two different categories of these sound sources. There's the airborne ones, just how loud is it up there? How loud do you turn up that AV system, blasting the music? How loud are people going to get while they're in there in that environment, and making predictions about that. And then there's also impact sound sources, footsteps on to the structure. On the footstep side, there are a number of things that we can do that are not that hard, don't take a huge amount of investment, but essentially insert a kind of shock absorber in the floor ceiling assembly or the roof ceiling assembly to decouple the structure that your foot is actually hitting, that roof deck structure, to decouple that from the structure, the roof structure that's actually part of the building structure. And by creating a resilient decoupling, you've basically got a cushion in the system, so that your foot hits the deck, and the deck may vibrate some in reaction to that. But there's very much like the shocks in your car. There's a spring, or in typical cases, it's actually some kind of rubber or neoprene type element that is providing a degree of isolation of that from the structure below. You can do similar things on the ceiling side as well. Same thing for swimming pools. If you've got a really big swimming pool, some rooftop swimming pools are pretty small, so people aren't swimming laps up there and doing cannonballs. But if you've got a pretty big swimming pool, then there can be a really meaningful level of impact and, but sort of a fair amount of energy imparted into the system, into the building system, that we can isolate. We can actually have an isolation layer around a pool. For the airborne sound, like, the loudness of a party, the AV system, if we can place certain limits on just how loud it gets, like maybe that rooftop system is going, but maybe we leave the subwoofers out of the equation so that it's not quite as loud. There's some things that we can do on the source side that are helpful. Once we address the source side, though, then you're looking at the path, which is to say, the structure itself, how heavy is that? Are we in a mass timber building, a steel building, a concrete building, a traditional wood frame building, et cetera? And then what's going on at the ceiling layer? So once you're inside the building, can we or should we do similar moves for the ceiling that we were just talking about for the roof deck? Can we or should we hang the ceiling on a resilient hanger to decouple the ceiling layer from the structure to provide an increased level of isolation from what's going on above? Of course, all that stuff costs money. And so a big part of this is around planning and around, where we need to do this and where we don't. Oftentimes we're able to save some projects some money if we can make good planning decisions early and have some of those activated spaces be over top of core areas of a building that are maybe less acoustically sensitive than, the penthouse suite.
Let's jump to the facade part of it, like facade design trends, and maybe how those are impacting acoustics within the building. So I mentioned jumbo glass. I know you did too.
Right.
Just glass and glazing. Other facade considerations, like different types of exterior materials, different interesting assemblies, like anything that's happening trend-wise on the facade design side that you're finding like it's impacting the work you and your team are involved in? Like, wow, we need to really figure out this acoustic problem that whatever trend it is causing.
Yeah, so certainly big windows. You mentioned jumbo glass. I mean,
Yeah.
the larger the glazing is, the more the glazing kind of begins to dominate the equation when it comes to how much sound from the outside is coming into the inside. And so that's certainly a consideration. And as I mentioned already, there's some things you can think about specific to glazing: laminated glass, thicker glass, insulated glass, air gaps, so forth, that are all related to that. Just as important, though, are what's happening at the edges. The joints, the mullion conditions, the stack joints. We need tight buildings, and we need that from a climate perspective. But we obviously also need that from an acoustical perspective. If you got a leak in your facade, sound's going to get through just as much as thermal bridging or water infiltration or whatever else. In those joints, if the joints themselves are particularly lightweight, hollow aluminum, or hollow, some kind of hollow extrusion that doesn't weigh all that much, then at a certain point your framing elements become weaker than the glass is, and we need to think carefully about those framing elements. So there's the glass, there are the joints, and then there are the framing elements themselves, whatever those may be. Things are a little different in like punched window type situations, right? Certainly if you've got heavy facades, precast concrete facade elements, for example, those have a great deal of inertia. That aspect of the facade is going to block a fair bit of sound, but we're still going to want to think through those joints and things. The other thing that is, certainly prevalent and can be an acoustical concern with systems like EFIS and those sorts of systems that are particularly lightweight. If they are lightweight, they're not going to block a lot of sound on their own. So we need to help them somehow, whether that's building a build out on the interior side or whatnot. There's another really big issue related to facades and acoustics, which is, I think, often overlooked. And that's because it doesn't relate so much to how much sound from the outside is getting in, but rather it's the role that the facade plays in isolation within the building. So, for example, if you've got a curtain wall building and you've got maybe a really robust floor, could be a very thick concrete floor with a ceiling below, and so you're well isolated from floor to floor. But then you tack a curtain wall onto the side of that structure. The curtain wall itself can be an end around. It can be a path for sound transmission from floor to floor that flanks, that goes around, circumvents the slab. So you might have this great slab, you have this great ceiling, whatever, but then the facade actually becomes sort of a chimney for sound to traverse from floor to floor around the outside of that slab. That's a huge deal. If you've got continuous vertical mullion elements that are hollow, that can run sound, right past the facade, that's a really significant weak link in what would have otherwise been a very high performing building. And so, in a building that's a punched window building where the facade sits on the slab, that's less of a concern. But in curtain wall assemblies, where your assembly is continuous alongside the slab, that's a big issue. The same thing can happen horizontally as well at partition connections to curtain wall mullion, for example.
And then, Ben, is that just a matter of insulating those framing components? The chimney effect?
It can be that easy. It is not always that easy.
Okay.
If, for example, you've got a single horizontal stack joint as the only thing between you and the apartment next door, that's probably a relatively lightweight element, and simply insulating it is probably not enough. Even if you've got a great fire stop seal between the slab and the facade, and so forth, that exposed horizontal stack joint element may be not enough on its own. And so you see a lot of buildings that on projects that we're engaged with where there's actually 2 points of engagement between the curtain wall and the building. You've got a slab condition, but then you've also got a sill condition above the slab, or a ceiling condition or a soffit condition below the slab, so that the building actually has 2 chances to engage this facade and a certain amount of air gap between those 2 horizontal elements that provide a greater level of isolation vertically. And again, the same thing can happen horizontally where partitions come in.